would you say? So I told you on Thursday when we started going over the 2-sample t-test that there was an additional condition that we had to check, and it was really, really important. What was that last condition that we had to check? Yes. What'd you say, Lisa?
Independent.
Independent. So when you have 2 samples, you had to check and see if they're independent. And I said that was important because if they were not independent, there's a different method. And so that's what we're going to go over today. It's what to do when 2 things aren't independent. So this front page, there's really not a lot to write down. I have most of the information there for you. So when it's not independent, that means there's 2 samples, and for some reason, they're very obviously related to each other. So it gives you some examples of things that would not be independent. So this is like a before and after. So if you measured 2 quantities before and then you did something and measured them after, those would not be 2 independent samples. It would depend on what you're measuring, right? And left and right. And you can see all the different other examples. So these are usually what is called a paired t-test because they're paired. They work in pairs. Make sense? And it says this comes from blocking when you have experiments. Anyone remember what that term means? Blocking?
Yeah, where you like separate them into 2 other groups.
Yeah, you separate them to groups, and then you do the same experiment on each group. It's basically you do the same experiment twice on 2 different groups. And then matched pairs. Surprise, a paired test comes from a matched pairs study. Okay, so skipping down. This is called a paired t-interval or a paired t-test. So that's the name. If you would like to write that down, you can. So when you do panic and phantoms and you get to the end, you're either going to do a paired t-interval or a paired t-test. Are you starting to get the hang of when do you do an interval and when do you do a test? Other than if it says, make a confidence interval, hopefully you know that that's an interval. If it says make a hypothesis test, that's a test. But there's some other hints if it doesn't say that. You know? Yeah, and like if it's a test, look for, it might not be these exact words, but you're trying to find evidence of something or testing a claim. So it's evidence of a claim. What are you doing when you make an interval? Like, what does the interval even tell you?
Just trying to find where the actual mean is.
Yeah, or in this case, yeah, mean. So it's an estimate of the population. Okay, so it might not be in those exact words, but that's what you're doing. Main thing is, if you're looking for evidence, you need to do a test. Okay, so when you do a paired t-interval or paired t-test, you're finding the difference between 2 groups. So, I don't even really know why I'm having to write this down, but I am. Difference means you do what? Subtract. So when you, remember when you go to the t-interval or t-test in your calculator, there's 2 choices. You can enter it as data, or you can enter it as stats. You always go to data when it's a list, and in this case, that's what you're going to probably do. So you'll have 2 lists, 1 for each sample. And since we're comparing the difference between the 2, we're going to make a 3rd list called L3, and you just subtract the 2. Because difference means subtract. And then after that, everything you do will be on L3. So it's like if you have a pair, you're subtracting every pair and finding how different each pair is. Okay, you probably won't ever do the stats menu with that. The only time is if you're given D, which is the mean of the differences. Question so far? Okay. So it's number 2 says use the t-interval or the t-test. That's talking about the calculator. So if you go through the calculator to test, you will find no paired t-interval or paired t-test. It's just t-interval or t-test. And actually, that's why the t-interval and t-test in the calculator doesn't say one sample. It's because sometimes you use it for one sample, but now we're going to use it for 2 sampled paired samples. Okay. So the one sample t-interval and the paired t-interval are the same thing in the calculator. The one sample t-test and the paired t-test are the same thing in the calculator. Think you can remember that? Okay, we'll see. I have the formula there. You know we don't hardly ever use that. There it is. Degrees of freedom. Remember that helps you determine what t-star to use from your table if you do it this way. And it's n minus 1. In this case, n is the number of pairs. So it's not just the number in the sample, the number of pairs in the sample. Okay, and then it tells you or shows you how to write the null and the alternative hypotheses. So it's either going to be equal to 0 and then less than, greater than, or not equal to 0. Okay, keep going to our favorite thing, the conditions. So most of the conditions are the same. What's our 3 main conditions we've been checking? What's the first one? So random sample, or if it's not stated, unbiased and representative, but you know that. And then n has to be less than 10%. And in this case, n is the number of pairs again. Okay, and then the last one's called the nearly normal condition. How do we check that? There's 3 ways.
Histogram.
Histogram is your last option. You hopefully don't have to check the histogram.
25
Over 25 or 30 is good. And there's one other way. Yeah, if it says approximately normal or if it says unimodal and symmetric, that means it's nearly normal. So it's either stated in some way n is greater than 25, or you have to check the histogram. And when you check the histogram, you're going to check it on L3 only. That's going to be the differences. That's different than in chapter 24 when we did 2 samples. You had to check 2 histograms. Now we're going to put them together first, and then you just check one. Less work. Yeah.
So can we do that on ClickForm?
No. Because in 24, you're comparing 2 totally different samples. Now we're just looking at the difference of them together. And like chapter 24, I'm going to show you how you kind of know. Like they don't even have to be the same sample size. Like if we did boys and girls in this class and measured your height, there would be a lot. I don't know if you have the same amount. I don't know. There's more, but it doesn't even have to be the same sample size. Interesting. There's one more condition. So when it's 2 sample, we had to check and see if they're independent. When it's paired, this is kind of dumb, but you need to state that they are paired samples. It's dumb because you wouldn't have gotten to this point if you hadn't already decided that.
Topic that way. It's kind of dumb.
No. Well, it is dumb because like you've already done all this. Like, oh yeah, by the way, these are paired samples, and that's what it is. But, and that means that they are not independent, and that's okay. They're very. Okay. And we're just interpreting how one sample. It says interpret the change from one sample to the second, or how they're different. It doesn't just have to be the change. It's not like it's always increasing or decreasing. Got it, Chandler?
Good.
Okay, set up so I can convince you're paying attention. Okay, turn your paper over. We got 2 examples. We'll go fast if you want. So pay attention. Okay, so let me show you how to know before we even read the problem. If you're looking at some data and you don't know if it's a paired samples or 2 samples, the easiest way to know is it important like what numbers go together? So if I'm looking at this example and I didn't know it was in chapter 25, it was on a test and I don't know what I'm supposed to do. It says The table gives the average high temperatures in January and July for several European cities. If it's a paired test, then these two numbers have to go together. If it was just two samples, then I could put 35 with 73 or whatever in any order. Okay, so do you see why in this one it's important that like 34 and 75 go together, and then 36 and 72 go together? Right, because they're from the same city.
Yes.
Okay. Like I said, if we were doing this class and measuring your height, it wouldn't matter who I matched up together. They could be mixed up. Okay, so that's kind of how you know which one to use. So it says find and interpret a 90% confidence interval for the mean temperature difference between summer and winter. So we're going to do a confidence interval. We'll go through all the steps. Okay, the parameter in this case, P stands for parameter, if you forgot. We want to tell what that is. We're going to use the letter D for, any guesses? Difference. Yes. It's the mean difference between summer and winter.
Do we have to?
Yeah, that like is your parameter instead of saying mu or yeah. Or you can either put D or mu of D. Now that's
Good.
I just keep adding things. Okay, let's check our conditions. A's assumptions are conditions. We think these cities are representative of all European cities?
For sure.
Sure. They're not all from one country, are they? Anyone know European geography? Sure. How many samples are there? How many pairs?
I feel like Copenhagen's in Finland, right?
I think so.
All countries? Of cities.
European cities.
Yeah.
Okay, and then the last condition, are we going to have to make a histogram or do we have enough information? Yeah, unfortunately. So, if you haven't already, let's type these into ToList. And since they're matched up, if you accidentally skip one, you can't just insert it wherever you want to. It has to be matched with the same thing in the other column, so you have to be really careful when you type these in or start over, and that's no fun. Okay, so once you have these all in L1 and L2, we're going to create a new list, L3, where we subtract the two. So you can either go through and subtract each one. You don't want to do that. Or you just type in, okay, we can do L1 minus L2 or L2 minus L1. Just looking at what the numbers are, what do you think will be easier to interpret on this one? Right. Do everyone know why? Yeah, just so it's not all negative. So you go up to L3 if you don't know how to do this. Go up to where L3 is highlighted, and then you just type in second 2. So you get an L2. It's right down on the bottom. Minus, and then second 1 will give you L1. And then when you hit enter, all the differences will show up. It's magic. It's great. Make sure you're up on the L3. And then that's all I know. I'll figure it out.
So can we,
L2 minus L1.
whenever we're interpreting this one, we're really trying to make it seem normal? I mean,
Yes.
okay. Like if it's close, we should
Yes.
go ahead and say it is.
If at all possible. Because you really shouldn't be doing this if it's not. Yeah, so on this one, okay, so we're going to look at the histogram. Just make sure you change it to L3 for your list. Is that what anyone else got?
Yes.
Okay, that one's not too bad. It's not normal. There's not a whole lot of data though. You could adjust a little bit if you want. I'll make it 10. That's even better. Look at that.
Wow.
Now it's not symmetric, but it's very unimodal now. Okay, so remember I said the bigger the sample, the less unimodal and symmetric it has to be. This is actually great for 12, because 12 is getting somewhat close to 25. If you have samples of size 5 or 6, it needs to be extremely normal.
How do you make sure that it's on L3 for your graph so it's supposed to stay on it?
When you go to the stat plot, make sure the X list says L3. And you just sketch it.
Do we need to describe it?
Yeah, so you just say somewhat symmetric and unimodal. Yeah, I can show you. So I just played with, you can do this, I just made the window more normal round numbers. I went from 20 to 75 and then 10. You can just kind of play with the numbers to get it a little more normal, or more, yeah, a little more normal. Any other questions? That's the hardest part of making this histogram.
What did you write after the graph?
Somewhat symmetric and unimodal distribution. You really want to be good, so you can say, so nearly normal is reasonable, or nearly normal model is reasonable. Yeah, I didn't figure. Okay, the rest is easy. So that were our assumptions. So what's the name that you just told you a second ago? So, are we doing an interval or a test?
We don't need that fourth.
What?
We don't need the fourth condition.
Oh, yes we do. Thank you. What's our fourth condition?
They're not.
Yeah, you can just say they're paired. Paired samples.
Do we also need to say they aren't?
No, it's fine. Okay, so now what's the name? Yeah, since it's paired samples, this is a paired T interval. And if you weren't paying attention earlier, you go to just T interval in your calculator. T interval. And if yours automatically goes to stats, mine did earlier today, just go back to data, make sure your list says L3, frequency is 1, and then is this 90%? Yeah. Calculate. So that's your interval. The only thing we have left to do is write our conclusion. Yes.
Mine was off by like 1.
Like one whole number?
Mine was 31.9 and 41.2. Is that okay?
Just make sure you use a T interval and not Z interval, because that uses a different model.
I did too.
You know the wrong button.
Yeah. You may just had one number in wrong. Yeah, you can just throw it off.
Not wrong. It's on the test.
Not like in points. This might be a half a point or something. Okay, it's not a huge deal, it's just a calculator error. So interpret this. We are 90% confident. Yeah, and it even tells you in this one what to interpret. So we're 90% confident that the mean temperature difference, run out of room, between summer and winter is 32.34 degrees to 41.33 degrees. Okay, this is going to seem like a dumb question, I think. It's kind of obvious. But since they're both positive, which one is bigger? Yeah, July, L2. And what else can I say? Oh, is there if it said, is there evidence of a difference? Or does this suggest that there is a difference between summer and winter temps in Europe? Yes. Again, it seems dumb, but why?
Zero's not in it.
Zero is not an interval. Very good. And it's kind of obvious. But. Second example.
Will they ever give us a problem and we'll have to do a T-interval and a T-line?
Yes. But that's easy because you don't have to repeat conditions. You don't have to repeat parameter. You really have all the data saved. It's like the last two things. Well, you'd have to write the hypotheses. More often, if you have to do both, you have to do a hypothesis test first. And it'll say, give a confidence interval to support your hypothesis. Which then all you'd have to do is that last part right there. But yeah, you do have to. In fact, you might have to do one this week sometime soon. Say on Thursday. Yeah. Maybe nobody's paying attention. All right, last question. So we have a table with the calories in strawberry and vanilla yogurt. So I hear everyone typing, so we'll just go ahead and put them in the calculator first, I guess. It doesn't matter which one you use for L1 and L2, but if you switch up the order, you better write down what you did for your own knowledge, I guess. Okay, so the question says, is there evidence that strawberry yogurt contains significantly more calories than vanilla yogurt? So is there evidence? That's telling you hypothesis test. Since it says we're trying to figure out if strawberry yogurt has more than vanilla yogurt, how do you think we should calculate L3?
L2 minus L1? Or no, L1 minus L2.
Right, we're trying to see if strawberry has more, so you kind of suspect it to have more. So I would start with the strawberry, just so it's positive. So you go up to L3 and type in L1 minus L2. Anyone having trouble, ask a neighbor if you can, so I can get to you. Okay, let's go through all the steps. So our parameter is our difference. So it's the mean difference in what? Yeah. In calories. The mean difference in calories, I guess, between strawberry strawberry and vanilla yogurt. Okay, H stands for hypotheses. So let's write our hypotheses. Okay, so the null hypothesis is always that the mean difference is equal to 0. There's no difference between the two, so the mean of all the differences is 0. And what will the alternative be on this one? Greater than? So we've got no difference, and this one's saying strawberries bigger than vanilla. Now I'm putting this over the side just to kind of write words, but you can't just do that. If you don't put it in symbols and you want to write words, you can, but you have to write it out like a complete sentence. Is that your question?
No, it's okay.
Oh, okay. Assumptions, conditions. Do we have random samples? No. You think these are representative yogurts? Any yogurt experts here? Yes. Just the only one I'm a little questionable. I think it's questionable. There's 12 again. Is that less than 10% of all yogurt? Are there more than 120 yogurts that have both vanilla and strawberry yogurt brands? Nobody knows. Maybe in the whole world. And
It's a weird one.
yogurt? What's up? It is. I think it's not originally English. Anyone know?
No.
Okay, we need to do more research. All right, let's look at the histogram. So when I just hit zoom 9, this is what the histogram looks like. That's awful. Y is part of it to the left of the y-axis.
Just negative.
You have more negative. So let's see if we can fix the window a bit. Not good. Worse. Not bad. Can you see it? So I put, if you want yours to look like mine, I put negative 20 to 120 and then a scale of 15.
That's the bin size, right?
Yes. So it's saying like 15 calories per bar. This one looks pretty good because... Okay, I'm going to draw this. But what do we call this one way over here, this bar? It's an outlier. It's only one, I think it's just one yogurt. Do you know which one? By just looking at the table? Yeah, the Great Value for some reason has only 80 calories in the vanilla, but 180 in the strawberry. All the rest are pretty close. So if you want to, you can draw the histogram and just kind of X that out because it's an outlier. But mention that. So without, you can say without the outlier, it's somewhat symmetric and usable. They're very nice. This is the conditions. These are the conditions. Okay. Because if I ignore that, isn't it pretty? I mean, it's definitely unimodal. It's not great, almost symmetric, but it's better. Better than the ones we were doing last week. Okay, we're almost finished.
What did you change
Fall asleep.
the window to see?
What? Why or what did I?
What did you change?
I went from negative 20 to 120, and then 15 for the scale. It doesn't have to be perfect. Don't spin forever on this. Just try to get it somewhat unimodal and symmetric. Okay, where are we? We did the sentence. Okay, so what name? What are we doing?
No, we need to do step 4. don't we?
We need one more condition. Just joking. What's the last condition? I'm glad you guys are paying attention. Now we can go on. Yes. It is a paired t-test. Right, Cody? And you try it. So go to your calculator, find just t-test. You're going to use data or stats? Data. Use L3. What do you put for the very first number? UO.
0?
Yeah, it's your null hypothesis, so 0. And make sure it says greater than.
What is the T? Is that like your?
The T is like a z-score,
Okay.
but for the T model, so it's just how far away it is from the mean, the middle. How unusual it is. 1.33 and 0.105. Did anyone get that? Good. Any questions about how to get that? Easy. Wasting your time. You already know this. Okay. Write the conclusion and we're done. Part 1 of the conclusion. We should start with 1, not 2. Are we going to reject or fail to reject the null hypothesis?
Do we always need to say our alpha level?
If it's close like this one, you probably should. So what are we saying the alpha is? It really doesn't matter too much, but yeah, we can say alpha. A lot of time it's given to you. Mainly state it like if it was 0.07, where it could be rejected or failed to reject, depending on what you use, then you should state it. Okay, and then nobody's going to miss this on the next test. If you fail to reject the null hypothesis, what do? Good. There is no evidence. And just go ahead and immediately write that. You fail to reject, failure is no evidence. And then figure out what am I even talking about. So there's no evidence. Look up, back up at the top. That strawberry yogurt contains significantly more calories than vanilla. Yay. That wasn't too bad, right? And that's chapter 25, done. We're reading very fast now. How many chapters do we have?
27.